I love and hate Hibernate.
Yeah, now it's becoming tricky. It's not very easy to understand.
If you're smart enough, you can spend money, you can hold money, you can earn money.
We are getting close to the top.
It's very good to be smart.
Hello and welcome to the new episode of the Architecture Deep Dive podcast. Today we have a great topic to discuss, a great guest to talk with, and we are going to dive deep into scaling of the databases in financial giants or monsters, which is Wise is. So I'm very excited to introduce you, Dmytro, a principal engineer at Wise. And Dmytro, to get started, could you please give a bit introduction of yourself and maybe a little bit about Wise, because maybe some of the people do not know the company. That'd be great.
Hello. Thanks for inviting. Happy to be here. So Wise is a global technology company, and we are building the best way to manage world's money. So with Wise, you can spend money, you can hold money, you can earn money through the interest, and obviously you can transfer money across the countries. So about myself, I'm a principal engineer. I've been in Wise for 9.5 years, so it's quite a time. I spent a good half of my adult life in Wise, I joined Wise to work on KYC problems, but over time I realized that I'm really keen to get to know more about the actual bread and butter of Wise. How do we do things? What makes us so unique and successful in our business? And after 1.5 years in KYC, I moved to finance team. And worked with it since then, and was maybe a bit more than 8 years with the finance.
That sounds exciting, yeah. But how did you land to be like the chief of the financial database at Wise? Just a historical reason, evolution? How come like you land this position or this responsibility?
Yeah, so I joined the finance team as an engineer, and it was a really small team back then. It was maybe 3 engineers together with me. And it was a time when we as Wise, we already grew quite a bit. So we started to be known as a money transfer business. But the whole company was really focused on success of the business and trying to ship new features to customers, build a better service. And with that being said, there was not that huge amount of focus on finance infrastructure, because when I talk about finance in Wise, I mean more that side of the things where we are taking care of accounting, everything that's happening in Wise, and where we are doing financial reports, which we send to regulators that our management uses to make decisions. So it was a bit less focus on that side of Wise rather than just powering our success for the main business. So the state of finance systems wasn't that great, and we haven't really followed the best engineering practices. But it was it's starting to be clear that we need to change that. We need to do more on kind of solid engineering principles to make sure that we can scale the financials. And for the finance, the data is everything. So we had started building up the database that we called the finance database. A lot of focus was actually just making sure that that database works well. We record all the things correctly, because there was a lot of focus on data quality as well. So yes, I've started as engineer in that team, but then briefly, maybe after 1 year, I started to be the engineering lead for that team. And we started growing team and the system more to accommodate for the growth of the Wise. So we got to have first 2 teams and then 3 teams. So at some point in time, I was helping and leading the 3 teams who were doing different things inside of the finance. But I never really been that kind of focused on the people leadership. Rather, I was trying to balance two things: helping people to build the best software and succeed in what they're doing, as well as making sure the system is scalable. And I was really focused on the technical bits. So for the whole time with finance, I was very much into details on what do we do with the system, what do we do with the database. So never really lost the hold on making sure that I understand all the details.
Yeah, makes sense. You mentioned a very interesting point and a very critical point, I think, in the financial world, like about the database, that is very critical to get it done right and to have the data correct and to have data integrity. Can you talk a little bit? What could possibly go wrong if you mess it up? If you make like a bad database design in softwares for financial sector?
Yeah. So when you think about the finance system, there is no more important thing than making sure that you have your financial ledger, like main accounting book, being intact, doing what it's supposed to do. And because of that, whatever you make as a decision, it will last for years. So in that sense, if you get it wrong, then it becomes a fairly big challenge to kind of revert, because you need to do costly data migrations. So from the first days, I would say the ledger design was very set in stone and it was very thought through. And I don't take credit for that, because that made the people who started working on that even before me. But yeah, over time we made a lot of great decisions and we made bad decisions. So, and as always, we had to fix bad ones and improve on the good ones. Yeah.
Yeah, and keep the good ones. Yeah, you're right. That's so true. So, like typically when you talk about databases and data reliability, the example people would give saying that, oh, if we were in financial sector, we would need this and that and asset transaction and data integrity. So yeah, those concerns are very, very important in this domain. Today we're going to talk a little bit about scaling the database. So I saw your talk on FWD's High Load conference, and there is a reason why we have slides, right? So from that talk, and I think it was great, and I wanted to highlight a couple of things from it. So can we talk a little bit about scale of WISE? I think you had a slide about that.
Yeah. So sure. Actually, that's growth of finance database, and our finance system is really reflected on the finance database itself. And the way how do we have the financial system designed is that everything that is happening in WISE product, like if I would use my card right now and I will go to buy a coffee, immediately in seconds, this data will land into a finance database as an individual transaction saying that Dmytro bought a coffee. So this is the real-time rails that we built to process data. And with that, you have a lot of opportunities. So you have the opportunity to build your real-time financial insights. You have the opportunity to build the real-time financial controls. At the same time, obviously, it comes with a great challenge of the real-time event processing platform. And also the scale is enormous, because as we process all activities which are related to money and we land them in the finance database, that means a lot of strain on the system and on the database. And actually, on this graph, you can see how how amount of data in our database grew enormously year on year. And this slide's capturing the end of 2024. And we had 25 billion rows in the main table. But I know updated numbers, and if I'm not mistaken, for these days, we are making 1 billion records into a table per month. So this is quite a bit of data flowing in. And
yeah, quite a bit. Let's say a little bit on that slide. So we'll go to data volumes in a bit. I wanted to ask you, what does it feel? Because this chart isn't linear. It's not a straight line. It's not a declining line. It's exponential, right? So it means from month to month, from year to year, you get even more transactions that you had before, right? So how does it feel like to be in such a team? What do you see like a change? What happens like, hey guys, next month we'll have like a double or like a 1.5 transactions that we had previously. Shall we plan? How do you plan for that? Like, how do you work with that?
Yeah, no, I would say that in our team, thinking about scale and about scalability is very kind of embedded in the way how do we operate. So when we see signals of things potentially failing in the future, that's at the time when we take actions, sort of. So we are very upfront planning for the capacity of the system to make sure that we wouldn't get to the breaking point, and we I would say there's a lot of efforts being put into it. So we do have just a lot of thinking and work on this. So when we understand that in a year we will have troubles, this is when we start already right now to make sure that it wouldn't be a trouble in the next year. And the observability is a big part here, and we have all the needed expected dashboards about the throughputs, about the latency of the processing, and we have quite active and periodical process to think ahead, making a forecast and trying to assess how would we be against that. There's one luxury that we have in the finance system, that we don't have that need to be uptime as much as wise customer-facing product has. So we sometimes doing this intentional simulation where we would take a 5-minute downtime where we will accumulate a load, and then we'll see how system process on its maximum capacity, how we can in production really see the ceiling of our scalability.
Is it done by accident or some kind of a test you would do, like just delaying in events and create a spike for yourself to see how would it go?
Sometimes it comes by accident, but I would say that because we have this opportunity to do this intentionally, we will just stop the processing and then we turn it back on to see how system behaves on the maximum possible load with the backlog of the events to be processed.
Yeah, it's very much reasonable. I don't think I ever heard about this approach, like just delay events a little bit and then create a spike and see how it goes. And I think it's very smart. Yeah, I'm glad you shared that. What kind of load do you have under normal operations? I think you just picked us a slide about that. So yeah, could you talk about that a little bit?
This slide is slightly outdated. I think the presentation was some time ago, and seeing that exponential volumes, I would expect these numbers to be bigger now. But I think what's really interesting about the finance system that we are building is that we have a lot of different data streams that are incoming into our financial service. And you can see here we are consuming more than 100 different topics that are in some way reflecting the money movements in Wise. This is roughly 80,000 events per minute to be processed. And on the database side, because there is a factor of load multiplication, we create multiple transactions from the single event. We would receive up to 20K transactions per second on the database itself. So yeah, there is quite a bit of load, I would say.
With that load and increasing exponentially, how do you scale? Right, you raised one topic in the in your talk that databases aren't really easy to scale. What do you mean? Like, what do you think about that? Like,
yeah. So that slide that I had about scaling databases, the thing is, in our days, maybe from let's say 2018, 2017, we got to have Kubernetes presented in many places, and people kind of learned how to scale compute fairly well. But it's not the same thing with the relational databases. Majority of the market on databases is still occupied by MySQL, Postgres, MS SQL, a bit less of Oracle these days, but it's still like those four giants that are taking majority of the market. And people generally don't go into sharding of those databases just because it's fairly complex and it's not out of the box for sure for those databases. So that's why the only common way to scale databases, I mean, when I say common, I'm thinking about majority. It's not that no one is doing this. No, there are some technologies that allow you to shard both Postgres, MariaDB, and MySQL and everything. But yeah, commonly people would scale database vertically because it's a known and straightforward path just by beefing up the machines. And that's why database scaling is more complex. Yeah.
But why do you need to scale? Like, doesn't it work like just fine? Just throw the data in?
No, unfortunately, it doesn't. Like the more you get transactions, the more you get the load on the database. You have the database hungry for more resources. So this is pretty straightforward way to see. As you see load increasing on database, you will need to beef it in, so get a bigger. So
Yeah. Oftentimes, database become a bottleneck in many applications. Sometimes the application itself becomes a bottleneck before the database struggles. But in your case, like going this path with Wise and seeing it transforms from a smaller company to a bigger company, would you consider that database was the biggest bottleneck for your operations, or not?
Yeah, for my domain, 100%. This is always a database that will be a bottleneck, because we have a lot of flexibility in Wise how we can, pretty much any engineer can increase number of machines on the application side, because we run Kubernetes, we run the Docker images in Kubernetes, and scaling there is fairly straightforward. So we can spin up the new instances of application very, very easily. It's kind of just a couple clicks thing. Not the same thing with a database. With a database, you need to get someone from database engineering team to power up more resources into it. And just in general, I've seen that deep understanding of database is not super common in just generally application software engineers. So yeah, that's why, maybe also because of the lack of knowledge, database is often a bottleneck. And this graph is actually the real graph that I took one day from seeing the load like latency distribution in our major processing paths. So, and yes, it's mostly a database. I would say more that even for majority of businesses that we have now, they would run sort of CRUD applications that are reading data, persisting data, updating data. So, and it's always a database that's under the hood. Yeah.
Okay, so if we decide that we put that sharding stuff aside for a while until we need it, what are the ways for us actually to scale the relational database? I like your approach, like from starting simple and going into more advanced technique. Can we talk about that pyramid that you had in your presentation? I really liked it.
The pyramid that I have in mind starts from the very basic. It's very interesting because when people would see the problems with the performance, they would generally approach them through the lens of their knowledge and skills. When engineers being taught how to write Java code, for example, when they see performance issues, the first thing that they will do, they will just go and try to find the issues within their application. They will run the profiler on the application. They will find these hotspots, and they will try to optimize maybe for memory. They will blame garbage collection for being slow. This sort of things. And I guess just comes from the expertise. And not that often people will kind of take a step back and try to think, okay, I have this application, I have this database. Is this database powerful enough to process the data volumes that I have? And because people would not take that step back, they will keep optimizing something that is fairly efficient. So if you remember that diagram, they will keep keep tackling that time in JVM. And it's just not always a very productive way to do things.
We just need a better garbage collector,
And yeah, that's true. That's all. Then, yeah, it always can be better.
Yeah.
Yeah.
So where do we start with databases? Okay, we figured that the database is like the main time consumer in our app or in our use case. So where do we start? Where is a reasonable place to start?
Yeah, I would say that for me, it's always to understand whether this database is rightly configured and whether it's powerful enough to process the load that we have. So first, I will just make sure that it's correctly configured, because it's a very anecdotal story, but I've seen many examples where systems in production have been for years and they still were running on their default settings. Because no one just thought about that. And especially when you have a very large company, and companies nowadays do microservice architecture, so they will have 1,000 microservices, they will have a couple hundred databases that will be under those microservices, and then you will have 5 database engineers in the company, because hopefully you have a right automation. And it's not guaranteed that those database engineers will put same amount of efforts and attention into each database, and very likely this many database will be just on default params. And what's really cool is that it fairly understood way how to put the correct params for the database. I believe for Postgres there is this website where you just plug in your machine configuration, and it will give you the params for the database. It will tell how much shared buffers or whatever else params in Postgres you would need to put in. Yeah, starting from there, if you see the params are correct, if they are tuned for your workload, then from there you would need to understand, okay, is this database big enough? Does it have enough resources? And if it doesn't, then the pretty obvious path in my mind is to see if that's reasonable, just to add a bit more.
Yeah, for sure. Okay, cool graph. Could you explain it a little bit? What happened here?
Yeah, this graph is kind of shows the insights into that specific example that I had in past, where the first part of the graph, it shows a CPU, and you see there is this breaking point. Before the breaking point, the CPU was very often coming into 80%. And database was clearly struggling to do what people wanted to do. And then the second graph about actual latency of the process that were running on that database, it shows a really heavy spikes. And that was all materializing into the issues for the business customers. So the processes were delayed, they were not executed timely. And the trick there was pretty much just increase the machine capacity. And we paid $548 for the month for whole 3 instances. And yeah, it was just a bigger EC2 machine on AWS. It's funny because you would not want to pay more, right? You would want, I'll just optimize all the things and I will have the same machine. But sometimes if you're talking about $1,000 for something that is really, really important, then it's just worth the money. Like you will have engineers spending just a couple hours for the same amount of money. So sometimes it just makes sense just get a bigger machine and go with it. That's it.
Yeah, for sure. And sometimes in cloud environments, you do not know actually what the upgrade will give you, because sometimes like you check what the basic numbers, like the CPU count, RAM availability, or like a number of gigabytes of RAM. But sometimes it's like, oh, I get a better network and now it works better, or I get a better deployment group and my virtual machine deployed on a better server because my requirements are higher. And it suddenly works much, much better than you would expect with a simple change. Totally agree with that. Can I ask, like, do you run those databases because on virtual machines, or do you use some managed solution like RDS? Because here I see, like you mentioned, virtual machines, EC2s.
Yeah, so this example, for the transparency, I want to say that this database and these numbers is not for our giant database that's running 20,000 transactions per second. It's just some
Okay.
other example that I picked up from my finance domain. So it shouldn't be, one should not think that, this small machines can handle all the load. Yeah, so in Wise, we run AWS RDS, and it just was one of the few databases that were on the old setup. But yeah, it's our strategy to go with a managed AWS solution.
Okay, I see. I thought I can get like, I don't know, $1,500 and set up my own wires on 3 machines. Doesn't it work like that?
No, probably not.
Okay. So yeah, settings for database. You're totally right that defaults are good as defaults and they work until they doesn't. Sometimes it's more tricky to change or modify settings with setups as RDS or managed database. Not all of the providers give you a lot of control when you actually buy pre-configured managed database from them. So I wanted to ask, like, what are the next steps? Let's say we think that it's configured well, that cloud is managing database for us. What do we do next?
Yeah, just want to make a remark about this thing that I feel like if you reach this point, when you see that cloud provider doesn't allow you to change something that you want to change, to me, it feels like a sign that you need to move on and look for your problem somewhere else. Because in my experience, the RDS out of the box, it works very well. Like for many use cases, it doesn't need to be tweaked in that default settings. So if you feel like you need to change something with RDS, but you cannot, and you need to figure out some workarounds, to me, that's a sign that maybe your problem is somewhere else.
Yeah.
But
Makes
so
sense.
that's why I'm sorry. To me, this is like a base ground. So once you get the setting more or less right, and you still see your things doesn't work, then it's time to move on and think about something else. Yeah. So this something else for me in database world, it's indexing, because it's the most straightforward thing you can do. Like if you don't have an index set up correctly and you have table that is bigger than 20 rows, you might start having the problems. So that's time when you need to think about indexes. And yeah, like to me, indexes is a so basic thing that everyone should think about indexes. Okay, I'm creating this table, I'm designing it, I need to think how it will be used. And then if you see any performance issue, first thing you check, okay, like, do I have index here? And yeah, that's very obvious thing.
Yeah, it is. And oftentimes, I see the problem the opposite. Like not that we don't have indexes. Like too many things are indexed, because it's very easy to just add an annotation in Java, for example, saying field indexed, right? Okay, I want to sort it by that field, and then you have like 20, 30 indexes on a table, which is having, I don't know, 50, 60 columns, something like that. So what is an approach? Like, do you have like any things that you'd say? Like, good approach, bad approach in terms of defining indexes, creating indexes, evaluating them?
Yeah, 100%. It's funny enough because in past I've often heard people asking this sort of interview question, right? Like, oh, maybe you just add the index for all columns and expect that argument that I should not, because I will have the inserts slow or this sort of things. And I would say in a real life, when you have a big enough table, then it's pretty obvious where you need to add index, because you will see your application being unbearably slow if you don't have index. So it will be very easy to understand where you do need to have index. And there is many tools that can be used to understand where they are excessive. So there is even in Postgres there is a table with statistics where you can easily understand that indexes are not being used, so it's worth dropping them. So it's quite straightforward path. I would say that in real life, it's not that easy to spot those excessive indexes, because you will have too many of them, and yes, you will have the insert time slower, but it will be hard to see those like milliseconds difference if you have a good enough machine, if you have a good enough load, so it will be hard to spot. So that's why you need the statistics from database to understand what you should do.
Yeah, and some of the managed solutions kind of try to give you a hint saying, hey, you have an index that hasn't been used for a couple of months. I saw something like that from different database, different vendor, from MongoDB, Atlas. They would do that. They would say, hey, you have a couple of indexes that aren't used at all or haven't been used for a year. Do you still need them? So the tooling here is very, very much appreciated if it's present, or like the knowledge how to extract that information from the database itself. You're right. Okay, I see another story, right, about indexing. What do you have?
Yeah, this is the example where indexes, while being so straightforward to understand, sometimes it might cause you a bit of pain. So this example is when we actually had the index, but the index was wrong. So this is interesting thing that happened when you are, like this example basically shows you where query on the database, explain, analyze, was giving you fairly good results. It shows that index being used, all good. But then in reality, this is the graph with you see it shows a backlog of events that we failed to process. It shows that index wasn't working. So the story behind that is that we released the application and we used Hibernate, and we have a pretty large table where we have different columns types. So some column types are strings, some are numeric values. And in this specific issue that we have here, engineer put a string value in Hibernate where it should have been a numeric value. So what application was doing, it was converting integer values into strings. And then for the database, it was searching for the string. So you can see here this select query where it was converting the number into text to search for it. And this is this example where, although you have an index, but this index is a numeric index, so you would not be searched if you convert the field to that text. So yeah, this is example where it was like this interesting setup where index existed, but it didn't work.
Yeah. You needed like to give it a thought, like to spot the problem, and not straightforward for sure. But yeah, looking great. Let's say we are done with indexes. What's up next? What do we do next?
No, it's application itself. So the way how I build this pyramid is that you start with the most obvious things. So you are doing something that doesn't need to be thought too much about, and then you're moving to more complex things as you see your application scaling and you cannot manage the load. So sometimes you have a database set up right, you have the right indexes, but then it's your application that's doing a lot of, I would say, silly stuff. So sometimes you would have unnecessary loops. You will have n+1 problem from ORM. There's many things that can go wrong. So this is a time to give a hard thought about, am I doing the right thing? Because more than often, people are not doing the right thing.
Yeah, happens. Do you have a story maybe about that, or example how it happened?
Yeah, on the presentation, I had this meme here about database engineers and application developers arguing who is in charge of database being slow and application being slow.
Classic.
Yeah, story.
We need to add a DevOps there. Who'll be complaining that the network is incorrect, or developers complaining on DevOps the network is bad, connectivity is bad, something like that.
yeah, thousands of such things. So the example here is it's actually from our monster database and from our monster application. And I showed before that we have more than 100 different Kafka topics that this application consumes and processes. And because you have so many different things incoming into your application and they behave really differently, it's sometimes quite hard to spot the issue with one of them. And this example is a good showcase for this case, where things are not working terribly wrong, but at the same time they are not working as good as you would want them to work. So here, it was the case where we had one of the caches not working properly. So we just had some sort of master data, relatively small table in database, but instead of caching it on application side, we were just constantly hitting database to fetch the pretty much the same data almost all the time. And and we just when we understood that, we added the application level cache, and actually was, I wouldn't say that's like end of the world or game changers. Changer was to add this application level cache, but yeah, it was 4 millisecond latency for our 25 something millisecond latency for one event to be processed. So yeah, like not bad, 15% improvement with, I would say, one line code change, just cache annotation, and that's it.
Yeah, it's looking great. What did you use for a cache? Do you remember? Like, was it a Redis or in memory cache in application
No, it was
itself?
caffeine. It was caffeine cache on the application side.
Okay.
Yeah. It's actually it's a very good question, very like sidetrack from what we are discussing. But I sometimes feel people are a bit too excited about distributed cache, like they will put their whatever. But in this example, as I'm, for example, talking about, there's really like a very small table, and there is no need for it to be cached somewhere outside of your application. By putting it somewhere outside, you're just spending network latency on going in that place to pull it from the distributed cache. Just much more straightforward way to cache it on application side, and job done.
Yeah, for sure. You must have Hazelcast. You must have, yeah, for sure. That network latency with cache is very often, I agree. So sometimes you will trade in the slower query to database, the faster query to cache, but then it's not that fast. Then you need to make a round trip to update data in cache. And then sometimes like it doesn't worth it, like just an adding external theme, replacing another external theme, right? So yeah, it's cool. That's why I asked. Yeah. Okay, so we are adding more and more, and now we're more efficient. What's the reasonable step to make next?
Yeah, I would say once you figured out the most stupid things you do with your application, once you address them, then might be a good time to give a hard look into your queries to the database. Actually, how do I use my database? Is it the efficient way to do it? And I'm putting this slightly higher than actual application fixes because I'm building this pyramid from the perspective of application engineers, from software developers. So on myself, I am not the database engineer. I spend most of my time developing applications, but just because of my fate, I had to work a lot with the database. And I would say that for engineers, it's sometimes it's a bit hard to make the step and to go into the database, explain plans, to understand what's actually being wrong, especially if you have application that is doing a fairly complex business logic inside of the database. So this is the building block when things start to be a bit more complicated. Yeah.
Mm-hmm. Yeah, so what would be the approach? Are we still looking slow logs and checking the queries we couldn't optimize with indexes and try to optimize those?
So yeah, it's a good question, but the way how do I generally start about the performance optimizations and about scaling is I would start from the business process. Like if I understand that this is my business process and it's slow, or I'm not sure that it will scale with a load, I will take the end-to-end latency for the business process as a whole, and then I will go with decomposing it into the smaller pieces. And at some point of time, obviously, I will understand that this is the database or maybe something else. In our case, we are talking about database. So once I would understand this is a database matter, then I will go deeper with the more specific database tools. Like, for example, the Percona gives the excellent insights. We have AWS RDS insights into performance. There's plenty of tools. How do you understand what your query is doing? And sometimes you understand even why it's slow if you think hard enough.
Yeah, it can be quite a bit of a trip to find the way like to optimize the query and find the query you want to optimize, right? Because sometimes in the modern frameworks, they're pretty hidden by the layer of ORMs and that magic transforming your repository calls into database calls and vice versa, right? So it's I don't know, like you said you're working with Java, so do you use Hibernate as well, right?
Yeah, it's one of the things that I really like to talk about. I love and hate Hibernate. I love because it makes things so easy and straightforward, but I hate it because you do need to know how to use it. I would say when you're starting with Hibernate, it looks very, very nice. But then at some point in time, you start realizing that it's a bit more complex than it is on the surface. So it's like right abstraction is very helpful until it doesn't, until you need to go into details. And I would say that if it's a large-scale application, it sometimes pays off to just get rid of this abstraction and take your JDBC driver, take something as straightforward as Spring Data. Okay, maybe like Spring Data is a bit more of the abstraction, but the idea I have is that once you have more load, once you have more complex applications, it makes sense just to skip abstractions and go more directly to database. So then you can stop relying on magic and you have more control about things. So yeah, and Hibernate sort of matured a lot, I would say, in last 10 years. I remember in 2016, Hibernate was a good thing, but then there was a lot of unexpected things, like you would get out of memory because you have a second level cache set up wrong or that sort of stuff. So yeah, but I would say now it's pretty good, but still, like I'm the person where I see I just want to have control there.
yeah, you are spot on that you need to know your tools. Hibernate is just a complex tool to know to reason about. Okay, I see another chart. I like these graphs when it's like bad, and then rapidly good. So what happened here?
Yeah. So the story here is that while we have really real-time focused applications, so we try to process everything as it comes, it's inevitably that there is some batch process here and there. So this is the example for one of the batch processes where we were kicking in the process each, I don't remember, maybe like 10 minutes or something. And at one point in time, it stopped to complete in those 10 minutes that we allocate for it because of the volume of data that we were processing. So, and it was a good time to give a thorough look into what this process is doing. And the query to blame was something that is very similar to this from SQL on the screen. So it was pretty large common table expression thing that had 5 queries underneath. And it's it's a territory where things become complex. So it's hard to understand on the get-go what's wrong. So and we had the database engineer who helped us to figure out the issue. And the problem was that because the query was fairly complex, the query planner and the Postgres itself, they were not doing the right thing. So in that sense, that if you see the example of what we've done after the change, they've broken down the query from 5 subqueries of common table expression to individual queries. And after each subquery, we were creating temporary table, then that was later analyzed. So what it gives you as a result is that you are giving the easier job to the database. It sees the table, it has it analyzed, which means that its kind of data is correctly laid out, that statistics are fresh. So database have an easier time with its with the query planner to use this data. Fairly complex example, but I just want to illustrate with it that sometimes you need to break this complexity down into the smaller, more manageable pieces, as well as help the database for managing this data better. Yeah.
Yeah, now it's becoming tricky. It's not very easy to understand, like why this should help, without deep knowledge of Postgres, or maybe like its internal mechanism, how to approach such a query and such a alternative of a query with temporary tables. You wouldn't be able to make such a change like without an experiment, right? Because on the surface, it's not clear. Like, would it help? Will it make it worse? Like, what is the way you would experiment with such a thing? Like, how would you test it?
I mean, that's like it's a really good question, but I wanna bring up something that that really resonated to me. I've a couple of weeks ago I was listening to the podcast of the person who is I think he is from Azul, and he's working on the garbage collection a lot, and very much into low-level optimization details. And what he said in his podcast is that it's very easy to be smart when you have a data. So, and I want to draw the parallel to this example here that if you are smart enough, which kind of what was the case for our database engineers, they were very smart to give explain analyze to the query and basically say that, okay, we see that the query planner is confused here, like it's just not doing the right job. And they immediately understood that what needs to be done. So it's very good to be smart. But I would say that, like as always, there's many ways to do this. You can have your pre-production environment, you can have a staging environment. If you have a big enough amount of data, then you can experiment there. You can run different query plans. So it's, like to me, the good opportunity is to have that flexibility to do your thing somewhere and see how that works. But it's real good when you're smart enough, then you don't need to do this.
Yeah. That like confidence can come only from experience, right? If you've seen that similar pattern maybe somewhere else, or you can have like an educated guess based on analyzer data, you really understand like what's going on. Yeah, that true. Works. Okay, we're getting more and more dangerous with all this stuff here. So what's next? What's the next step?
Yeah, the next step is about workload segregation. So it's about using your all available resources, I would say. Because oftentimes what I've seen is that people have a highly available setup of the database. What I mean is that there is a primary, and then there is standby, where change is being replicated, and then in case of the failover, when your primary is dying, then you can switch to your standby and keep your operation as normal. So it's a very common setup to have the couple machines, one or two normally, keeping behind of the primary, and then receiving changes from the primary, and just being there for just in case thing. I've seen that people are not really using that standby machines. So they are there for high availability purpose, obviously, but people missing on that thing that you can use it for your read queries, for example, because sometimes there's just a lot of queries that don't need data from the primary. So you can very well route your read request to the read replica. And this way, you're getting much better performance because you're starting using machine that was not utilized at all from the one side. But then from the other side, you're getting much more for the money you pay because you're suddenly not paying only for the primary reads, but you're also kind of getting the benefit of the machine for which you already paid. This is your standby. So this is about the kind of workload segregation between the primary and standby. This is just like a kind of intro into workload segregation when you just have your normal database. But then more and more, we get into this territory where you have not only those maybe read requests that you need to worry about, but also like some big analytical scripts. People want to run some analytics or some kind of more complex workloads on your database. And this is the time when, as I put it on my slide, is you start seeing that pressure for the database as business grows. as you get more and more use cases on your database, there's just more pressure. So like those analytical scripts, those reports start to be run, and your database is not anymore what's known as an OLTP database, online transaction processing, but it starts to become more like a data warehouse and analytical storage. So yeah, this is about what I meant about workload segregation thing.
Yeah. And I'm glad you mentioned that now we are kind of getting into the territory of eventual consistency, knowing when we can query the master node, when we should go like to secondary node, tracking the lag of synchronization if it's needed, something like that. Okay, so yeah, we split our use cases. We're starting to use and leverage replicas more. We tried to cover some of the analytical use cases with replicas. What's next? What's up next?
Yeah, the next thing is to basically figuring out where to put what things. And for primary database, it's generally just a real-time transactional processing, and especially focusing on your insert updates pairs that they just cannot go anywhere other than primary. For standby, it's a good place to put your batch process if you have some, maybe read queries as well. But it's important to not start pushing everything from your analytics into your read-only database, because there is this inevitable feedback loop from the standby into primary. So you don't want to overload your standby as well. And the good place where you can put it is the data lake. So you just ship your data into data lake or data warehouse, something like Snowflake, something like Apache Iceberg. So, and then you are serving queries from there. It's very efficient, very cost efficient, quite fast to do large aggregations. So yeah, it's a good way to solve the problem of not killing your database with analytics.
Yeah, I think that this is like the natural place people start. Like, we have a database, why don't we run this report and that like newsletter based of it, or I don't know, some summary aggregation. Oh, I just run this query on Slave. I won't hurt anyone, right? So I just totally agree with data lakes, data warehouses. You mentioned Snowflake, Iceberg. So database, we segregated our workloads, separated them by different use cases, split them to replica, moved out analytics somewhere else. Still is not working as we would like it to work. What can we do next?
So yeah, it's a time when you start thinking about whether all data belong there, whether all the data that you care about should be sitting in that same database. And I put it as quite high in this pyramid, because this is the step where you need to be very committed to doing something. Because generally, it's much more straightforward to split a service into more services to do what's known as a modularization, but it's not that easy with a database. I've seen many examples of modularization initiatives, and they often tackle services, and then data comes later. And what I've seen is that the data modularization being quite complex, where it would take maybe even years from the place where you actually already split the service to the place where you're splitting the database as well. So, but at some point, people just need to do it. People understand the need for doing this, because the database cannot really longer scale that efficiently. And one thing that I want to mention that's probably a bit like nuanced, so I didn't include it on the conference, but oftentimes it's not just about not being able to scale your database, because you still can probably scale the database vertically. And even AWS, they have the bare metal instances, huge ones, obviously a lot of money to be paid for them. But the other thing that you need to realize is that by splitting your database into multiple pieces, you're able to tune those databases much better for what they're supposed to do. So at some level of scale, it start become nuanced, that you understand that for one database, you just need to put in more into the disk. You need to have a faster disk. For other database, okay, I understand I need to put a bit more into memory, so it started to be nuanced. And just in general, when you try to optimize one database for all the things, you almost inevitably come with a very expensive thing, because you need to have a big CPU resources, a lot of RAM, and very fast disk. So yeah, it's just more cost efficient as well to break down the database into smaller pieces.
Yeah, but how would we go about that? Like, do you have an example? How would you break down database, or maybe a story about that?
Yeah, I do have a story.
I'm glad you do.
Yeah. So the story here is that in Wise, in general, we have been approaching modularization projects from a domain perspective. So inside of the single domain, we identified that it over time becomes a bit too large, and we kind of try to segregate subdomains from there. And similar, I would say, with the database. So example of our 37 terabyte monolith was that we kind of going a bit more in details. We understood that there is a domain of accounting where we need to create our main ledger, like main accounting book of Wise. We also have identified that there is a domain of controls. What are the confidence that we give for the users of our data? This will be our controls that we run on top of database. And as a result of those controls, because we are controlling for each transaction that happened in Wise, we need to persist some data as well. So we realized that, okay, there is this domain of accounting, there is domain of control. Okay, let's get them separately, because that was also a setup where we had already by that time different teams who were working on those domains. So it was a fairly natural way for us to split it into domains. And just kind of first pass, I would say, is to split by domain, and then inside of the domain identify subdomains, maybe to split it even farther if needed. So yeah, that's how do we approach it.
So sometimes with such a split, you see the parts, you see like, oh, this actually goes here, this goes here, and it like splits naturally. You see the boundary, but you still have some communication between those two, like maybe data sync, maybe request, maybe some supporting data like a lookup. Did you have something like that in this setup, and how did you solve that if you had that?
Yeah, we had it. And this was it's actually one of the most challenging parts about splitting the database, because oftentimes people will start with, let's say if we talk about Postgres, it will be a single schema inside of the database, and people will just have tables in the same schema for one thing, tables for the other thing, and very naturally there will be a substantial amount of those queries that will overlap multiple tables. At some time, you understand that those tables supposedly should go into different schemas. So you need to logically separate them, because as in our example, we had this accounting domain and we had the control domain. So we introduced two different schemas inside of the single database, and we moved the tables which belongs to different domains into different tables. But still, we have this cross schema joins. So this is something that we needed to just heavily break into pieces. And the way how we've done this, that we moved that control aspects into separate microservices. And instead of just basically using some table as a queue, we started publishing data into a Kafka topic, and that other service started consuming from that Kafka topic and writing data back into the same database. It was the same database, but different schema. But what it allowed us to do is not to do this cross-schema joins. And it eventually allowed us to pull that data out from the database when we stopped having that cross-schema joins inside of the single database. So it's I would say this basically become as a pattern. How do we break the services? How do we break a database? It's just route communications through either APIs or through Kafka, and over time you see there is no dependency, so you move things out.
Yeah, I think it's a very good approach, and to take out those connections and make them application levels when you need them, when they are not like crucial because otherwise you would not split those tables into two separate domains. Anyway, you would otherwise. Yeah, so that sounds great. Okay, I see a new level. What have you got here?
Yeah, so at some point you understand that, okay, I have these small domains, I don't want to break it even more into domains, because sometimes it will just feel very like artificial. You would realize that, okay, maybe it's not a different domain. It's the same domain. So like I don't want to break it into the pieces just for non-functional requirements of scalability. Partitioning is the one thing that we normally do for the fairly large tables. And I would say that's, maybe partitioning sometimes even go before data modularization, because sometimes it's even more straightforward thing to do than data modularization. But I would say as scale goes, first people will start thinking about data modularization, but then they will realize maybe problem is inside of the database itself. So partitioning is basically breaking a single table into multiple pieces. And this is hugely relevant to Postgres database, not that relevant for InnoDB-based databases like MySQL, MariaDB, because Postgres has this has one very bad thing. I mean, it's not a bad thing when you know how to deal with it, but something that people complain a lot about Postgres is the vacuuming process. Sometimes it's auto vacuuming, but vacuuming in general. So it's a big deal with the Postgres, and for many, it's a reason why they go away from Postgres. But yeah, there are ways to solve it. Partitioning is one of the technique where you don't have that huge table, so you break it into smaller pieces. And then management of those smaller pieces becomes easier for the database. So vacuuming kind of just becomes easier for the database and doesn't hit performance as hard as it would otherwise.
Yeah, that's great. And this is like a first step into sharding. Maybe we're not talking about sharding here, but still you need to partition your data somehow. What was your approach into partitioning?
Yeah, so we've gone with a pretty, I would say, straightforward way, because we as we are doing financials, it's very natural for us to close the financial period and move on, because we in the end of each financial period, and in our case the smallest that we have formally approached is a month, because when we close the month we are closing the book, which means that there is no other records should come into previous months, because it means the data is locked, it's being reported on, and yeah, there is nothing we can do for modification of the data. So because that very natural financial process of closing of the financial period, we understood that the very good approach is just break the table by months. Yeah, it was really kind of good and straightforward thing to do. So yeah, and maintains tasks. Yeah, sorry.
Yeah, makes sense. That month close and financial thing, is it like an external process that's going on? I mean, are you required to close the month at the end of month and do not modify data, or is it something you developed in this particular case?
No, it's generally in accounting, in finance. It's a kind of standard thing that you do. So you're kind of closing the book and then you're submitting the reports. It's closing the months, closing the period as months. It might sometimes be internal thing, because it can also be related to when you need to submit your reports. For example, regulators might want you to submit reports yearly, but you decide that it's just easier to close month by month, so you don't have too much of the work at the end of the year. So we made that decision to close the book monthly. So we just, okay, we've done the work, we understood everything is correct and fixed for that month, and we move on. So it's just kind of breaking down complexity a bit.
Yeah, makes sense. And it's great that it kind of matched here, right? Or you chosen like a smart approach of doing that. That's also true. Good. So with data partitions, do we have anything else that we can do? We are getting close to the top.
Yeah, getting closer, yeah, climbing up. So I would say that this partitioning, it's generally not specific to finance application. I don't want people to think that they can partition only if they close the months and they don't modify records. It's no, that's not true. A lot of applications that people work day by day is very time series based. Something happened, then something new happened, and then naturally, as time goes on, those things that happen in past, they are not being modified that much. So it's kind of more generally applicable, not only for finance applications.
Sure. Yeah.
And very connected to the idea of partitioning and moving things by time basis. Once data is really not being touched much, the very natural thing is either you delete data completely because it's not needed anymore, or you move data elsewhere. And in our case, it's a second. So we move data into archive because we don't really need it as on a regular basis. But sometimes there are use cases where even old data, years old, need to be queried for some either investigations or just as a part of the bigger transaction that is happening over years. So we would move data from the database to archive, and for us it's normally cold storage. It's S3 based storage in AWS, and we will do this from application. We will just put data into the Kafka, and then there is a consumer which will be writing data into AWS S3.
Yeah, very natural process. We've been there. Okay, I know that you're annoyed with this question because I keep asking it and asking it, and you keep answering it very nicely. But still, do we have anything else? Like, can we do anything else?
Yeah, it will be in my mental model. It's going to be horizontal sharding, where you start doing multi-master setup, where you have multiple instances that will be serving the modification requests. So this is very, in my mind, the top league game, because not many reaching the place where they actually, because of the load, need to break the database into the multi-master setup. And yeah, the reality is that with our even large and loaded databases, because of the techniques that we've done in past, like the archival, like breaking into the smaller databases, we haven't even yet got to this place where we actually need a horizontal sharding to be done with our database. So we are happily taking care of all the load with a very decent headroom, even with our definitely not the biggest, not the most expensive database. Yeah, so this is the game in my mind.
Yeah. I have a question here for you. What's your take on elastic databases, serverless databases? Isn't it a solution without going in sharding? Did you consider using something like AWS Aurora Serverless?
I would say AWS Aurora is a good solution, but even AWS, they're not positioning Aurora as a distributed database. They not too long time ago, they released a product they call DSQL. If I'm not mixing up the names, because they sometimes get cryptic, but AWS these days, they do have distributed database, something that they claim to be truly distributed database. And there are other solutions, like there is TIDB, something that's getting momentum. There is also YugaByteDB. So there are solutions for the distributed, distributed workloads, distributed databases. Actually, one very popular is Cockroach database. People use it for geo distribution. So yeah, I mean, those things, they are great. But and it's very likely that in future we will get into those databases. But in my mind, using distributed database, distributed SQL database, if you come there because you cannot handle the load with your database instance. I mean, it's very valid reason for the internet scale companies like Google or something, where they invented that spanner database. But if you are in kind of regular business and you feel like you are not able to handle the load with your single database, instance, to me it feels a bit odd because there is so many things that you can do before that to address the complexity, to address the scale. So I think there is many things that people can do and without going into distributed database. The thing with distributed database is that the cost is there as well. So you do pay. You do pay with money and you pay with the people time that need to manage this complexity. Obviously, as we in the industry, we get better, we get smarter. So this database is easier to manage. So maybe not that much of the overhead, but yeah, you need to pay for someone for that.
Let's put it like this is definitely not a place to start your journey, right? With the database, like from a distributed database.
It's like I recently heard the talk from someone who is providing the horizontally scalable solution for MySQL on top of was this popular? I think it's Galera or something like that. This horizontally scalable solution for MySQL. So they package it and sell as a product with a control plane and stuff. And exactly this question was asked, like, okay, should customers start with distributed SQL? He said that yes, like many customers start with that. If you have a lot of money, if you're willing to spend them on your distributed database and you're sure that your business will be successful, maybe it's a way to go, but it's kind of highly unlikely.
Yeah. Do you have a number? Like, I think I saw the number in your presentation, like that this approach helped you to scale hundreds X, something like that. Isn't that right?
The deal is that there was this slide with the graph and
no.
Yeah.
In the very end, I guess you had like that 400X scale.
Okay, yeah, maybe I'll just get there.
Sure.
Yeah. So there's no single thing that get you there. It's just all the things in different point in time that you make that let you really manage the complexity and scale. So yeah, that was exactly the story for us. It's not that you're at that index and now you can scale infinitely. It doesn't work like this, unfortunately.
Yeah, unfortunately, I would love to know that index or that line of configuration you need to change. That would be a beast. Sure.
100%.
Okay. I think like you shared like plenty of knowledge for somebody to get like really dangerous with databases and know enough to be dangerous. Dangerous in a good way, to scale it better, to work with it better, to achieve great results as you did in Wise with your financial database. I just wanted to ask, maybe a couple of advices or thoughts you wanted to share at the very end of this podcast with our listeners. What would be your take on that?
I would, there's no magic bullet or anything like that. Just in my mind, if you talk about scaling, it's, first and foremost, it needs to be data driven. So you need to understand your problem very well. You need to understand your weak spots. And this means a lot of groundwork on observability, on setting up that visibility of your problems, being able to identify the bottleneck. And once you understand what the bottleneck is, then you can go really deep. And there's a lot of tools that help you optimize things. And especially if you are talking in 2025, you can use your ChatGPT as a rubber duck. It will definitely help you to scale things. So just kind of go deep and learn from whatever is available on the internet.
Yeah, I like that very much. Thank you so much for joining today and for sharing your wisdom, for sharing your path and your advices. They are very valuable, and I think they would be very useful to many, many people here. So to our listeners, I'll say keep listening to our podcast, like and subscribe, drop a note in the comments for Dmytro or reach out to him in LinkedIn account or whatever. Dmytro, thank you for joining today and sharing all of that. I really enjoyed the conversation, and thanks a lot. And I hope we'll see you in the future in new episodes of this podcast.
Yeah, thank you. It was an absolute pleasure.